Ow! Ow, 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 ow!
Now playing Distracted with Brian Pulaski.
Wicked mind, you hold power, put my mind into the power!
When I was younger, my dad used to tell me something that I remember to this day and have passed on to my own children. He used to say, Brian, look up. Just look up at all the amazing things that we have that surrounds us every day. One of those things is one of the coolest things in nature, and I think it often gets overlooked. That is our moon. Our moon is a natural satellite that orbits around us every single day. And I think we kind of take it for granted at how awesome it truly is. Being the only natural satellite means, not counting the things that we've put up for television, for radio, for GPS, those would be all unnatural. The moon is the only natural thing that goes around us. The moon comes around us every single day. It rises and sets about 50 minutes later every single day. So if it rises at 6 a.m. on one morning, the very next morning, it's going to be rising roughly around 6:50 a.m. So you can see it every single day. One of the confusing things that boggles my mind is some people think that you could only see the moon at night, which is completely untrue. Just start opening your eyes and looking up. You're going to see that the moon is out during the day as well. The moon is fascinating because it's on a orbital period and a rotational period that is synchronized. It is completely identical. So what does that mean? That means that the moon, if it's going around the Earth, and if you're watching the video, you're going to get a whole lot more out of this. The moon, as it goes around the Earth, is called the orbit. The rotation is what it does when it spins in the sky. The moon is fascinating in that it spins and orbits at the exact same speed. What does that mean for us? What that means is we always see the exact same side of the moon. Often that is called the dark side of the moon. A complete myth, because there really is no dark side of the moon. Both sides get light. Just look at the phases of the moon and you would understand, but we will get into the phases of the moon in a little bit. The orbital period and the rotational period is the exact same. So when you look at the moon, when you look at the moon tomorrow, if you looked at the moon yesterday, it's always the exact same side of the moon. And that is because the rotation is the exact same speed as the orbit. We just always see the exact same size. The moon is about 238,000 miles away from Earth. That's a lot to comprehend. A better way to look at it is if you took 30 Earths and stacked them next to each other, that's about how far the moon is. If you were to get in a space shuttle and you wanted to go stand on the moon, it takes about 4 days just to get to the moon. The size of the moon. If you were to take a common basketball like I have on the table right here, if you had a basketball, the basketball would represent the Earth. This softball that's right next to the Earth, or right next to the basketball, would represent the moon. The moon is about a quarter the size of Earth, which is humongous compared to the solar system. If you were to compare the other 150 so moons that are in our solar system, our moon ranks 5th in size. However, the top 4 moons are all moons around the gigantic Saturn or Jupiter. So by comparison, we have the absolute largest moon to our planetary size. And that is a bit of a mystery because it's kind of unknown on how that could happen when we have these giant gas planets of Jupiter and Saturn, which theoretically should be collecting bigger moons than what they have, but they don't. We hold the record for that. We have the biggest moon to planetary size, and our moon again ranks 5th in size of all moons in the solar system. In fact, our moon is so big, it's bigger than Pluto, which used to be a planet. There's many reasons Pluto is not a planet, but there's yet another reason that we could argue is that our moon would theoretically be a planet if it's going to be bigger than Pluto. But that's for another episode because planets aren't technically ranked by their size. There's many things. The age of the moon is about 4.5 billion years old. So if you think back, 4.5 billion years old, our Earth was just starting to form. It was very hot and it was starting to come together. It was a ginormous mass. In fact, our solar system was very busy with tons of objects circling and flying around the sun and trying to figure out what the heck is going on. And as we're forming and we're huge, we're this giant lava mass, a mass the size of what is now Mars comes and bam, hits into us. Not a direct hit. It's more of like a glancing blow to our Earth. That glancing blow shaves off or knocks off a chunk of what was Earth. So what you get is this big explosion of an object the size of Mars banging into Earth at a glancing blow, knocking off a huge chunk of Earth, exploding this big chunk from Mars. And all those pieces kind of come together as the physics of space makes, and they start to spin together and they start to create what we now have as our moon. And our moon at this time was much closer to the Earth than it is now. The Earth's gravity, being what it is, starts attracting the moon, and the moon is not solidified yet. It's a glob. And as a glob, it starts to pull and it becomes tidally locked. Tidally locked means one side is always facing another side. It bulges, and one bulge was constantly attracted to Earth, and that tidally locked the moon as it orbited around the Earth. And as that happened, it starts to cool. And another one of the huge mysteries of the moon is that the face of the moon, the side that we constantly see, is completely different than the backside of the moon or the dark side of the moon. In fact, the crust, the outer surface of the moon that we see with a telescope is bombarded with pocks and marks from craters and things hitting it, and seas and giant lava flows and all kinds of what looks like lava tubes and all kinds of craziness. But if you look at the other side of the moon, which they have pictures of it, it's completely different. In fact, the surface of the backside of the moon that never sees or never faces the Earth is much thicker than the surface that has faced Earth. The reason for that, or they hypothesize, is that the Earth was attracting the moon, so it tidally locks the moon in, and the heat from the Earth as it's forming is just scorching and burning this face that is facing the moon, not allowing it to cool as fast. The dark side that never faced the sun at this time starts to cool faster, starts thickening up, and it became much harder, thicker, and a different structure than the current face of the moon at that time. So then, the moon starts to push away or starts to orbitally move away from the Earth as it is right now. It moves about 1.5 inches away from the Earth every year. And so now we have the moon at a distance of about 30 Earths from us, and much further than it was when it first formed, but kind of created this craziness in the moon, in that it created this the face is much different than the backside, and that's because of how it formed. At least that's the theory on how that goes. Earth's gravity is tidally locking the moon. So we talked about that. Tidally locking is what the moon is now doing to us. If we were to get rid of our moon, if it just boom, flick, gone, what would that do? Well, one of the things that it would do, and it might not be as immediate as movies would lead us to believe, it would absolutely affect our tides. In fact, our tides are a direct result of the moon. As the moon is orbiting around us, the moon is attracting by its own gravity. It is sucking on the water, the lakes, in fact, around the earth. But, obviously the oceans being the biggest water surface that we have, sucking towards, not sucking, pulling the water towards the moon, creating a bulge that is constantly facing the moon. The inverse side of it is also a bulge. So now you have these two bulges, one bulge that faces the moon and the other bulge on the opposite side of the earth, directly opposite of the moon, that circle around, creating your high tides and your low tides. If the moon was gone, our tides would quickly dissipate. It wouldn't be as quick as maybe movies would lead us to believe, but probably within 10 years, we probably wouldn't have much of a tidal rise and ebb and flow, as they would call it. It'd probably only be maybe 6 inches or 8 inches. Not a whole lot. So what does that do for creatures that rely on our tides, that rely on our coastal regions? The fish, the arthropods, all the different insects and stuff that live inside the water and live in our tidal system, they're dependent on that. There's crabs, there's different animals that work upon the lunar phases. All that would be gone. Sea levels would change, of course, because they'd be leveling out. They'd always be at a constant. You wouldn't have a whole lot of up and down. The coastal regions of all places around the earth would change because the water would go up. It would level off. So the structure of the earth or the coastal regions would look much, much, much different. It would change a lot. The main thing it would change, though, to be very quite honest with you, is that right now the Earth is on an axis. It's tipped, right? So if you have a North Pole and a South Pole, they're not directly straight up and down. It is tilted. It's tilted about, if I could remember, 23.5 degrees. And that's what gives us our seasons. So we have seasons because of the tilted axis of our Earth. Well, the reason we have a tilted axis on our Earth is we're spinning. And the Earth is maintaining that wobble and allowing our axis to maintain. So if the moon went away, boom, it's gone. All of a sudden, we would wobble more, and our axis would probably adjust. They predict somewhere between 10 degrees to 45 degrees. That's major. That's a major change and something we would not want on Earth, and it could be catastrophic to all of mankind. Scientists say that the last time we had a significant axis change in the Earth was about 1 or 2 degrees, and they say that's probably when we had the Ice Age. So if you think of all the things that happened drastically to all animals, big deaths of dinosaurs and all kinds of craziness, that was during the Ice Age, and that was only about 1 or 2 degrees. If the moon was gone, we'd have a wobbly Earth, and the axis would change and likely have about 10 degrees to 45 degrees of axis change in the Earth, and that would not go well for us. Before I end it, I got one last little tidbit, a fun little fact for you on the phases of the moon. There are technically 8 phases to the moon. Phases being as you look up and it looks different. We all know what a full moon looks like, but there's different parts to it. There's the full moon, which is the whole circle of the moon. The opposite of that would be a new moon, where you can't see the moon. Why they say you can't see it? You know you can see it. It's still there. It's just blacked out in a shadow. You can't really see it very well. So that would be just 2 of the 8 phases. The 4 of the main phases is, you could just think about the new moon would be like 0. So new moon is 0. It's nothing. Then you have like a quarter moon. Then you have a full moon, then you have a 3/4 moon on the other side, and then a new moon again. So we got 4 phases right there. In between, they have the different odd names. You could look it up. There's waxing and waning. Waxing's when the moon the sunlight is getting bigger across the moon. Waning is when the sunlight is getting darker across the moon. There's gibbous. the crescent. Okay, so they have all these different names from to be very easy and a fun fact, something you can go out and show your mom and dad if you're a kid that's watching this, or tell your kids about this. My God, go teach your kids about this. I will never forget my dad teaching me this, and it's the coolest thing, I think. The phases of the moon spell DOC, D-O-C. Okay. So you have a new moon. New moon would be nothing. You can't see anything. And then the moon starts to grow and it gets bigger. And as it gets bigger, it's waxing. And as it gets bigger, it eventually is a quarter moon. And that first quarter moon looks like a capital D. Okay, so you have D for DOC. And then the other side starts to lighten up. And now you have a full moon. That full moon looks like an O. So now you have D-O. And then now the moon phases start to wane. They start to wane, and kind of like lost my train of thought. Starts to wane, and then eventually it wanes and gets to a 3/4 moon, and eventually into that little crescent, and it looks like a C. So we have, if you're watching on the video, it goes D, O, and then it starts to wane and it goes away, and then it looks like a C. So you have D, D-O-C, like doc like your doctor. And then eventually, as that C wanes enough and it goes away, you go back to a new moon. So don't remember 8 full phases of the moon. You just remember the 4. You know, you got you got a new moon, a first quarter, full moon, third quarter, and back to the new moon. DOC, DOC. You can always look up in the sky, look at the moon, and see what phase it's at. And a fun fact, because you could always turn to somebody next to you and say, do you know whether the moon is getting bigger or if it's getting smaller? And you can always tell. Because if it looks like a D, it's getting bigger. And if it looks like a C, it's getting smaller. That's a little bit of info for you guys about the moon. I hope you guys enjoyed it. I love space. I'm sure you've noticed that about my tattoo. Super into it. Maybe next time you're getting fascinated and thinking things are amazing in social media or all this distraction that we have around us, maybe you could take some advice from my dad. Go outside and just look up. Lots of stuff out there for you to see. Appreciate you guys checking in. We will catch you next time. Later.